Hello guys, so welcome again for another challenge. So this time we'll take the Cyber Defender's Banking Troubles. So this is a memory analysis challenge with a little bit of malware analysis. And there's also shellcode, which I have a little bit of difficulty in the meantime. But anyways, I will manage to answer most of the questions. So yeah, let's proceed. And I will also introduce to you a new way to analyze a memory automatically, right? Not entirely automatically, but it will do all the analysis job for you. And it's also Windows based, but it will have support for Linux later on, based from the author. This is a very useful tool from Solomon Sonia. Very great. This was presented in the last SNAS DFIR 2022 Summit. I'm a fan of all things SNAS, so check it out, guys, and I will showcase this to you in answering this challenge. Of course, you can still use the same old command line volatility analysis, but later you will very much appreciate what I'm talking about once we get into the actual solution. Okay. Okay. By the way, I've set it up in our Windows VM, so of course you have to install it. I mean download it and set up. You Once you were able to, okay, just check. Once you're able to set it up or export it in your Windows machine, just make sure that you have imported the actual uh, volatility standalone. This one. Without this, you will not be able to perform the analysis successfully. So the link was also given by Solomon here. You can download the standalone executable here, and you have to set up everything correctly. So once everything is set up, what you need to do is you can let's go back. Just double click it and make sure also it has a dependency. Of course, since this is jar, you need to install Java on your analysis machine for the jar file to work correctly. Simply double click it. Uh, okay, let's try from scratch. I'll close this. Yes. So once you have set it up, double click. Okay. Just wait for it to load. Okay, this is actually GUI click interface. So very easy, no need to memorize any command line at all. It will ask you the very first, what's the memory image that you will analyze with the tool. Okay, let's just wait for it. It's still loading. There, the console shows you the logs being performed. Okay, there, almost done. Of course, I would recommend you give your virtual machine around 8 GB and 4 cores or 8 cores if you must. Because if you just give it a 4 GB RAM, it will surely hang most of the time based from my experience. Okay, let's here the first step, select memory image to analyze. So we will point it to the BMEM from the challenge, Banking Trouble challenge. Okay, point it. The thing here, you have to do your assignment here because it will ask you the profile to use. Okay, and right now I've already done it previously, so this one will use WinXP SP2X86. Okay, let me pause here. WinXP SP2. Okay, yes, so this is the profile to be used. So that's the prerequisites here. You have to know the exact profile. Click OK. Okay, you can specify your cyber. Okay, cyber. Investigator name, a description, some case number, or what's the case being all about. Okay, we can try banking troubles. Click OK. Okay, the key thing here, you could the beauty of this tool is that you could select any plugin you like and it will run it for you. Okay, let's try. So for example, if we want the base to run the basic PS list, you can search it here in the plugin search. Okay, click on that and then select analyze. It will analyze it for you automatically. Okay, no need to memorize the command line. Okay, but you have to familiar with each plugin and what it does. That's the thing. Okay, I will show you. It will save the output to a text file so that you could reference it anytime you like. So that's the beauty. So you don't have to run the plugin each time. Okay, there. And then we have the output here. Isn't that great? And then of course the automation part, you could click the advanced analysis automation. You can click initiate advanced analysis and it will run every plugin here that it knows. And it will store all in a location. I have run it previously. It will store it in a folder, structured folder. So every plugin with a specific output. Example this, callbacks, so callback output, the con scan, remember this, everything. But you just have to give it around 20 to 30 minutes, depending on the specs of the VM. Isn't that great? Even the dump file or the file scan. So imagine here the dump, even the DLL file scan. See, there's a file scan, there's even a dump, DLL dump, even the actual DLLs, proc dump. Okay, so all that's left for you once it's completed is to proceed with your analysis, right? So that's a very great help in the memory analysis realm, memory analysis forensics discipline. So I really highly recommend you set up this tool in your analysis machine. So this is a great help. But of course, there's a flexibility in command line that cannot be catered by this GUI. Later on, I will show you there are questions that we still need to run the volatility command line. Okay. Of course, I also recommend you to watch the video guide. Solomon there will showcase the whole features and capabilities of the tool. Okay, without further ado, let's proceed with the challenge. Okay, okay, question one. Let's proceed with the question one. What is the local IP address of the victim's machine? So going back, so here we will use the connections plugin. Okay, so we already have the output. Remember, I have pre-run the automated analysis before. Save the time. So let's open the connections. Here we can see the local IP of the machine is actually this one, right? Okay, which is there. Okay. Okay, number two, what was the OS environment variables value? Okay, found this. So again, using the Xavier tool. Instead of running commands, choose the plugin you want from the automated analysis. This time we will inspect the environment variables plugin. So Simply open the output. So it's rather convenient, right? Than waiting for the command to run. So you can see the OS path has the value of Windows underscore NT. Okay, easy peasy. Okay, 3, what was the administrator's password? Okay, so remember volatility can do hash dump. And actually we already have here the output from the Xavier framework. So if you open it, here are the dump hashes. So of course we are asked to crack this one, this administrator hash. So what we're going to do, I already copied it in my Linux box because I'm going to use John the Ripper. Notice here, I've already copied here the hashes found in the hash dump and save it into a hash.txt file. And to crack it using John the Ripper, this is actually the command john-format equals NTLM hash because these are NTLM hash in the bank. Then point it to a word list of common passwords being used. I already have saved in the home Kali downloads and rapid.txt space, and this is the hash.txt which contains the hashes to be cracked. Okay, simply execute it, give it some time, and it will output to you the cracked password. Okay, remaining two password hashes with indulgence. Okay, perhaps I would do it because the file has been cracked before. So I will try to copy it to a new file, hash that text to hash that text. Okay, see. Okay, then we'll try to crack it again. Okay, with no different salts. Okay. Just troubleshoot a little, so we have to clear the john.path file, previously cracked password, in order to run this again successfully. So after it's done, so we run the same command, and notice it was able to crack administrator password. Okay, so that's the answer here. Password. Okay, next, which process was most likely responsible for the initial exploit? So here it's quite obvious. Remember here the challenge details. Okay, I think I forgot to mention in the intro. So challenge details is really it's one of the employees received email pointed to a PDF file. Upon opening, there's unusual activity, and we all know that for opening PDF, this acro-rd 32.exe is the suspect process, most likely the involved process. Acrobat Reader 32. Of course, we could verify in the Xavier output. We could check the of course, we could check the PS list. Of course, to get the process ID. In the PS list, we can see acro RD32 has PID of 1752. Okay, the next one, of course, is to check for any. We could try the conscan to check if there's any malicious connections. Okay, recall 1752, and true enough, it's connecting here. This IP. Okay, we could try virus total. And as we can see, okay, it's quite clean, but okay, later we'll analyze further. We could also try to check, remember, for any injected process, check the malfind. So malfind tool is also here. Malfind. So notice here, there's also injected for a specific process. Okay, so that's for. Okay, what is the explanation of number 5 of the malicious file retrieved from the process responsible for the initial exploit? Okay, for this, of course, we're going to inspect the related files, DLLs, directories reference by the process responsible. So we're going to use here the handles plugin. Okay, handles plugin for this one. Okay, so let's investigate the handles output. We're going to look for the PDF and the process ID of 1752. So let's try to run a bash here. So we could use grep. Okay, we could grep 1752. This is the Acrobat Acro Reader 32, Acrobat Reader 32.exe. Okay, and then do an additional grep looking for PDF. And see here where I find this malicious PDF file as a handle to that process, malicious process, right? It's a file handle. Okay, so that's where we're able to get this. It's a PDF extension. And then the suspicious process open network connections external IP. Okay, recall we have found this in the conscan output. And this is the malicious process investigated earlier in the earlier questions, and this is the IP. Okay. Okay, number 7, suspicious URL was present in the process SDC host.exe memory. Provide the URL that points. We have a clue here, PHP page hosted over public IP, no FQTN. So we actually found this. So the key here is since everything is not encrypted, in memory, we can actually do an easy string search, right? Okay, let's go back. Okay, we have here our BankingTroubles. Our DBM, hang on. That bmem, so let's do a strings dash a bmem, and then we're going to grab for the PHP. Okay, we could do this one, PHP, then do another grab for starting with HTTP, something like this. Okay, give it some time. Okay, that's quick. Okay, and as you can see, we already got some answers here. Okay, recall, I found this. This is a public IP. Okay, 8URB PHP. Already captured here, this one. Okay, so number 8, extract files from the initial process. One file has 75 hash ending. this string, when was this file first submitted for analysis on VirusTotal? Okay, so if you recall on the earlier, we found the 1752 malicious process ID for Acrobat Reader, right? PDF reader, Acrobat PDF reader. So what we'll do is hash dump, do a memdump, do a memdump for it. So actually, I'll show you. Xavier has not. If we go back to Xavier, so doesn't do. Okay, this one the limitations. It wasn't able to dump the malicious process here in our automated analysis. So what we're going to do is manual dump it using volatility. Okay, let's go back. Let's see. Flash profile equals WinXP SP2 WinXP SP2 86 x86. Okay, XP. Okay, then the process recall 1752 malicious process. Then we're directory to dump just in the same directory. You can click run. Okay, you can see above we remove it. I've dumped it before. Oh, sorry, forgot to add the profile, the plugin. So memdump-p. Okay, so we're able to dump it again. Writing, just give it some time. Okay, let's check. Okay, we got the dump file. Okay, it's a data file. Okay, we already have the 1752 memdump here. So the next thing we will use the foremost tool to carve files out of that memory dump. So you can install this now. I'll show you. Okay, this is developed by Jesse Conlon, useful tool. So to use this, simply type foremost, then the file. What it will do is it will create a directory and dump the carve files structured based on the file type. So you'll see very useful tool. Okay, there are errors, but one thing to check is there will be an output folder already. So as you can see here, you have the output. And as you can see, it has dump able to carve BMP, DLL, exe, GIF. I'm not interested in the PDF, so let's go to the PDF folder. We have a couple, and we could do a MD5 sum, all, then grep for the ending being asked in the question right here. This one. Okay. Paste. Okay, doesn't work. Perhaps from here. Paste. Okay. Oh, sorry. Type some. There. So this is our suspect file. So the next thing we can do is actually upload it to VirusTotal. Just like this, we only did. And you can actually see in the details. This is the date. Okay. Also 329 2001. Sorry, this one. 329. Okay, number 9. What was the PID of the process that loaded the file pdf.php? Well, we have answered this. Found this in the previous questions. If you will recall, I recall in the earlier questions we did found this 1752, which is the forgot reader 32.exe that also connects to suspicious IP. So yeah, there you go for number 9. This is 1752. Right. Then Q10, the JS includes a function meant to hide the call to function eval. Provide the name of the function. So we're able to find this. So remember, we have already dumped in the volatility. We're able to dump and find the malicious PDF file. So what we're going to do is I transfer that PDF file into my Renlox machine because this has the capability or the tools needed to extract JavaScript from a PDF or malicious PDF file. So here I prepared simple scripts, simple ways how to do it. So we're going to just run 3 commands. So the first one is we're going to prepare the dump file, okay, using this command. Then we're going to use the ppdf. Okay, I forgot to show you, I already dumped here the malicious PDF found in the earlier question, this one. And we're going to extract the JavaScript from it. So already prepared the dump file. Next is to actually extract the JavaScript using this command. Okay. So if everything works properly, so the JS from PDF.pdf should contain the extracted JavaScript. So we're going to view it now. JS from. Okay, and it's successful. And here, it's actually a long script, quite obfuscated. And actually, the answer is in the near the end of the script, wherein you can see function calling the eval right here, this one. So that's actually the answer here, HNTY XRFW. And for number 11, I really have a hard time yet analyzing shellcodes. So I failed to answer this, but we'll move on to the next. This is the only thing that I'm not able to answer right now. Okay, so we'll move on to the next. Okay, for question 5, process will log on .exe hosted a popular malware for analysis of the virus total on this date. Okay, pretty old, 2010. Provide the MD5 hash the malware. So here, okay, we will go again to our handy dandy Xavier tool. Of course, we're dealing with malicious processes. Okay, particularly with log.exe. So most probably it's already in the malfind dump. Okay, so This tool, it already did the job for us when we ran the automated analysis. As you can see, already has a dump of the uh, malicious winlagon.exe, or at least as a winlagon.exe that manifests process injection, because that's what malfind is looking for, right? So here we run bash.exe and we'll do an MD5 sum on winlagon, all winlagon.exe, all winlagon.exe. Let's do an asterisk, right? So it will just, okay, then we have to bash virus total. So we now have the MD5. So we'll look for something that has this value, right? And actually, we're able to find this one. So since we already have the answer, the last winlagon.exe is the one that has the matching first submitted date. Okay, I already have a screenshot here actually. This one here, as you can see. Okay, it's the MD5 and the first submission matches with 2000 March 29 of 2010. All right, let's go back. Okay, for Q13, what is the name of the malicious executable reference in the registry hive? And is a variant of Zeus Trojan. So for this, again, Xavier tool comes to the rescue. So we can actually find this on the file scan output here. So let's bash.exe here. So we could grab the output. So since we're dealing with registry hive, so okay, let's try wrapping system 32 first on the file scan output. Okay, actually here you could find something like, so of course you have to probably familiar what are the core system 32 binaries, and look for something that sticks out. So that's actually what's hard in memory analysis. Not everything really is automated, and you have to have a core understanding of those binaries. So for example here, this is something that sticks out because this is not common, mutable is not common. And when you actually Google it, this one like this, I have a screenshot already. This is actually related to a Zeus malware variant. Okay, so that's how I found this. Okay, that's for number. Okay, number 14, the shellcode for Acrobat V7 downloads a file named e.exe from a specific URL. Provide the URL. So here you can see the actual, the format actually gave away the answer. So give away some of the keywords with this parameter, and as an ending equals 2. So the easiest way to do this will be really using grep and do a string search on the memory dump. Okay, so right here I already performed the grep in advance, and actually this is what meets the answer. Okay, okay, if we try this, Control Shift C. Okay, okay, oops, okay, Okay, so I did a grep here. It's quite a lot really, so just bear with me on this. Okay, it's quite a lot of output. Okay. Okay, there you go. So, okay, we have to do strings like this and grep just HTTP, and we have to sort it and deduplicate it using var unique. Okay, and the answer actually is around the bottom since okay, so somewhere here. So remember the equals to. Okay, remember the format. If I remove this, okay, it has a double parameters, double end. Actually, these are candidates as well. These are strong candidates, so we try this one. Search, copy link. Okay, that's not it, and we can also try the other one. Okay, copy. Oh, not everything was copied. There, and there you go. Of course, there are other ways to go around it, but this is the easiest way. Okay. Okay, number the shellcode for Acrobat V8 exploits a specific vulnerability. Okay, provide the CPE number. So here we found this. Remember, if you remember in the question 8, we are able to find the PDF. If you recall, okay, we're able to extract the malicious PDF, and the output was located here. Remember this, the 006. Okay, this is the malicious PDF in the question number 8. So simply what we were going to do here, although there are other ways, was simply leverage the OSINT. So we could search by total. This is the malicious PDF, same file name, but right here there's no CVE Intel whatsoever. So the other option we have, you could also search here the related PDF reports. Also utilize Open Sandbox like the hybrid analysis. So we uploaded this, and notice here it was able to resolve the CVE as well. And that's the answer. Alright, so hope you learned a lot again. So see you on the next CTF.